Hello, how you doing? Hope you're doing well. Welcome back to another Biometrics episode. Today I'm going to show you a ZKTeco 4500 Node.js biometric integration demo. To get us started, let me first explain the various steps that I am going to take you through. I am going to show you the various scenarios that one could encounter when running the ZKTeco 4500 Node.js biometric app. The first scenario is where you run the Node.js biometric app without the ZKTeco device being connected to the computer. I will show you what happens when you run the application in such a scenario. In the second scenario, we will connect the ZKTeco device to the computer and then run the Node.js biometric application. Then I will show you what happens. But then remember that in the second scenario, we are not going to present a finger on the biometric scanner. We are just going to run the application with the ZKTeco device being connected to the computer. But then when prompted for a fingerprint scan, I will not present my finger on the ZKTeco device for scanning. Now, the third scenario is where we are going to run the Node.js biometric application with the ZKTeco device connected to the computer, and when prompted for a fingerprint scan, I am going to place my left index on the ZKTeco device so that it can be scanned, a fingerprint image can be captured, and a fingerprint template be extracted after the fingerprint scanners successfully completed. So to start off, I am going to open the CMD, that is the command prompt, and then after I open the CMD, okay, let us just get started. But before that, I need to show you the application in the folder from where the sources of my ZKTeco Node.js biometric application are. Here in this folder is where the files for my Node.js biometric application are. You can see this folder here, that is node_modules. That is where the modules are archived. In the biometrics.js file is where the code for this application is. And then we have the package.json file and the package-lock.json file. These two are usually very common in any Node application. So what I'm going to do right now is to open the CMD. So I'll just come here at search and type CMD. It is already even here, so let me just click it from here. There is our command prompt. We need to change the directory in the command prompt to where the ZKTeco Node.js biometric application is running from. So to do that, let me first minimize the CMD, and then I go back to the folder where the project sources of the ZKTeco Node.js biometric application are. Then I copy this path I right click, then I click copy, and then I minimize this, and then I open the CMD. So now what I'm going to do is I'm going to type E here, the letter E, full colon, and then I press enter. Right now we are in drive E. Now we need to change the directory to the path that we copied. That is the path to the ZKTeco Node.js biometric application. So I've pasted the path there, and then I press enter. Now as you can see, we're in the path. We are in the path where our ZKTeco Node.js biometric application is running from. So to confirm this, we could just type a dir command here, then press enter to list all to confirm whether the files there are the same as the ones that we could see from the web browser here. So now I'm going to press enter. So you can see we have the biometric.js file, this one here, and we have the node modules folder, this one here, and we also have the package-lock.json file, this one here, and we have the package.json file, this one here. So we can accurately confirm that we are in the correct folder. Now to run the application, we need to type node space, and then we have biometrics.js at the very end. So to do that, let me first copy this name here, that is biometrics.js, and then so that we have some space here, I need to type CLS. Sorry. Then I click, and then I press enter so that we clear the screen, and then we type node space biometrics biometrics.js. So now we have, oh no, I wrote mod here instead of node. It needs to be node space biometrics.js. So I press enter. So observe what happens. Take note that this is the first scenario where we don't have the ZKTeco device connected to the computer. So see what happens. So I've pressed enter. The application has run all the way to completion and returned us back to the command prompt. So this is what happened. So we could see the title of this one here. You can see the title of the application, that is Node.js biometric ZKTeco 4500 integration dash fingerprint capture demo. So, and then the application attempted step 1 for it attempted to initialize the ZKTeco, but then there was an error, that is error -1, which is error -1 during ZKTeco initialization. I already know what error -1 means, but I need to show you from the ZKTeco API guide what that means. But we know that this was not possible, the ZKTeco initialization was not possible because we do not have a ZKTeco device connected to this computer. So quickly let me take you to the ZKTeco API guide. Here it is. Then there is a section called appendix where we can see the errors. So I need to show you what -1 means. So this bit here, that is at appendix 2, where we see the description of returned error values. -1 here. So failed to initialize the algorithm library. So the reason why we could not succeed to initialize the ZKTeco API library is because the ZKTeco device is not yet connected to the computer. So once I connect it and we run the application, we are not going to receive that error -1. Again, I'm scrolling all the way to the top. Yeah, so let's minimize this. Let us minimize this ZKTeco API documentation so that we go back to the command prompt. Now I need to do CLS again to clear the screen before we run the application now in the second scenario. So I've done CLS and I've cleared the screen. Now what I need to do is to connect the ZKTeco device to the USB port of my computer, and that is what I'm actually doing right now. Let me fix it. Let me just plug it in here. So I've plugged in the ZKTeco 4500 device to the USB port of my computer. I am now going to run the application. Remember, to run the application we are issuing the node space biometrics.js command. So here it is, node space biometrics.js. So let me press enter. Observe what happens this time round. Remember, when the application runs and when it reaches the point where it is prompting us to present a fingerprint for capture, I'm not going to present my finger. We will do that one in the third scenario. So in the second scenario, we are just going to observe what happens when we run the application when the ZKTeco device is connected to the computer, but at the instance where we are being prompted to present our finger for scanning, we are going to ignore that bit. Then we let the application run on the way to the end, and then from there we'll be able to see what happened, and I will be able to describe what happened before we move to scenario 3. So remember that right now we are exploring scenario 2, where we just run the application and we are not going to present our finger when prompted to do so. We'll observe what happens. So now we are at step 6, where the application is prompting us to present our finger for scanning, but we are going to ignore that bit. So we want to see what happens if we do not present our finger for scanning. So it does this for 20 iterations, and after 20 iterations, if no finger is presented, it just runs all the way to completion and exits. So you will get this message here. Hope you can see this highlighted message, this message that I am highlighting here: fingerprint image not captured. If you do not present your finger on the scanner when the Node.js biometric application runs and prompts you to do so, it goes through these 20 iterations while it prompts you during every other iteration. So the first one, the second one, the third one, all the way to the 20th iteration, as it prompts you to present your finger on the scanner. But if you do not present your finger on the scanner, the application displays this message: fingerprint image not captured, and then afterwards it just closes the device, and then it frees up the ZKTeco resources and runs all the way to completion and returns you back to the command prompt. So far I've been able to show you what happens in scenario 1 where the ZKTeco device is not connected to the computer when you run the application. I've also been able to show you scenario 2, what happens when you run the application with the ZKTeco device connected to the computer, but then you do not present your finger on the scanner during that time when prompted to do so. Now I want to take you to scenario 3. Let us run the application again with node space biometrics.js command again. So the application is running. You can see now we are in step 6 where the application is prompting me to present my finger on the scanner. So see what happens when I present my finger on the scanner, the left index on the scanner. Did you see just what happened? So the application captured my left index finger and displayed this fingerprint image here. Let me move it around so that you can see it. This image here, this is the fingerprint image. If I go back to the command prompt, you can see that this is the fingerprint template that was extracted in step 8. This is the hash code of the captured fingerprint image, this one here that you can see displayed here. This is the fingerprint template that was extracted from the captured fingerprint image. In step 7 is where you see the display fingerprint image, this one here. So I had actually minimized it but when I clicked the command prompt, and you can see that we got this message here: fingerprint capture successful. So in step 6 is where you are prompted to capture fingerprint image, and a fingerprint template is extracted afterwards. Then in step 7 is where the captured fingerprint image is displayed, and you can see that in our scenario here the fingerprint image displayed successfully. We received this message because the application was able to capture this image and display it. And in step 8 is where you see display extracted fingerprint template, and there was this message here: fingerprint template extracted successfully. And you can see here it is. Here is the fingerprint template. You could actually call it the hash code of the captured fingerprint image, this one here. And then in step 9 the application proceeded all the way to step 9 to close the ZKTeco device. Then step 10 where it freed up the allocated ZKTeco resources. So you can see that it was able to successfully free up the allocated ZKTeco resources. Now I need to take you through these other steps, and then from there I will take you to the backend in Visual Studio Code to show you the code that I implemented to be able to run this ZKTeco Node.js biometric application. But before then, I need to at least have been able to explain for you step 6 for capture fingerprint image, step 7 for display fingerprint image, step 8 for display extracted fingerprint template, and step 9 for close ZKTeco device, and lastly step 10 for freeing up allocated ZKTeco resources. Now I need to explain to you step 1. Step 1 is where we were doing the initialization of the ZKTeco API, and you can see that we received this message, ZKTeco initialized successfully. In step 2 is where we get ZKTeco devices count, and you can see that we received one ZKTeco device is connected. That is a message that we received. And in step 3 is where the code opens the ZKTeco device, and you can see that we received this message here, ZKTeco device opened successfully. And in step 4 is where we get the width dimension of the ZKTeco fingerprint scanner, and you can see that the message we got is that the width dimension retrieved successfully, and then we got image width is 292 pixels. In step 5 is where we get the height dimension of the ZKTeco fingerprint scanner, and you can see that we got this message here, height dimension retrieved successfully, and that the image height was 374 pixels. So I've been able to take you through step 1 all the way to step 10, but now I need to take you to the backend so that you can see from the Visual Studio Code IDE the code that I implemented for this ZKTeco Node.js biometric app for finger capture. To do that, I think I am going to open another CMD command prompt. Or do I just use this one? Let me just use this one. So to open Visual Studio Code, I'm going to type a code and then a dot at the very end. Yeah, you can see we have code space dot, then I'm going to press enter now, so that I open the Visual Studio Code IDE, and we see what is in our biometrics.js file. That is where I wrote all the code for this Node.js biometric application app. So let me press enter. Visual Studio Code IDE is opening. Here is the code, it is initializing. So here we are in this file here, biometrics.js. This is the code that I wrote to implement the ZKTeco.js biometric application for finger capture. So let me take you briefly through the code. You can see that it is just a short piece of code. It is actually 243 lines of code. There's no other code outside this. This is just basically everything that I wrote to implement this Node.js biometric application. Let me scroll all the way to the top so that I start explaining from there. These are the modules. This bit here, let me highlight it. These are the modules that I needed to be able to implement this Node.js biometric application successfully. And then this bit here is where I show the name for the application. So if I take you to the code, here it is, this bit here, that is Node.js biometric ZKTeco 4500 integration for finger capture demo. Now let me take you to this line here. This is where we initialize the ZKTeco API. Now this is the other batch of code that I need to show you. This one, you see this one that is highlighted, This one, let me highlight it again. Oh, what is happening? Yeah, this code here is where I am making calls to the ZKTeco functions that I need to interact with when I am running this Node.js biometric application. So let me show you these functions here from the ZKTeco API. Here is our ZKTeco SDK API guide. So I need to scroll down to show you those functions. So here are those functions, the function description. So if you go in this document from page 5 all the way to, is it page page 12, here is where you'll be able to see the functions that you need to call from your Node.js application. So if I click the function description here, we'll be able to go through those functions. Here is the first one for initialization, and that is the one that I am calling here. Sorry, that is the one that we are initializing in this at line number 14. Now at line number 16 is where we are getting the device count. So let me show you that from the ZKTeco API documentation. The device count here, this bit here, this bit here. Okay, let's go back to Visual Studio Code. Now in this line here, in line number 21, that is where we open the device. Let me take you to the ZKTeco API so that I show you that function. Open device, this one here, this bit here. Let me take you back to Visual Studio Code. Now the function for GetParameters at line number 23. So the parameters that we will need to get are the parameter for width and the parameter for height. Here is that function. This is the one for set, there is the one for get. This one here, hope you can see that, and here is its function definition. So that is the GetParameters function. Then from our Visual Studio Code at line number 25, that is the capture function, and here it is from the ZKTeco API, this one here. So this is the one that captures the fingerprint image and extracts the fingerprint template. Back to Visual Studio Code. At line number 27 is where we initialize the ZKTeco function for close device. Now if we go to our ZKTeco API and scroll all the way to the top, you'll see that here is that function for close device. Here is its function definition. Let's go back to Visual Studio Code again now for the last function. The last function that we're implementing in our code is the function for terminating ZKTeco resources. So this one here at line number 29, and if we go back to our ZKTeco API documentation, you will see the function definition as follows. This one here, this bit here, and this is the function definition for it. So you need to call this function to terminate, to free up all the allocated ZKTeco resources at the very end. That is at step 10. Okay, So basically that's it for the functions. At least I've been able to show you the modules that I am calling in this application, and the ZKTeco functions that we will need to call from our Node.js biometric application. So let us start with step 1, where we initialize the ZKTeco device. So in step 1, we call this function here. Remember this one here, this one here. Now once we call that, if we receive a 0 after calling the ZKTeco init function, we return ZKTeco initialized successfully. Otherwise, we return an error. If I take you to the command prompt, you will see that in step 1, when the application ran step 1 for initializing ZKTeco API, we received this message: ZKTeco initialized successfully. Now let's go to step 2 for getting device count. Now in Visual Studio Code, in step 2, this one here, we are calling this function, and then if we receive a 1, we report ZKTeco device 1. We report 1 ZKTeco devices connected. If we receive more than 1, we return the message: use only one ZKTeco device at a time. Otherwise, if we do not receive if the outcome of this function is less than 0, we know that we have an error, and then we show the error message that was encountered during retrieval of connected ZKTeco device. So in our case, you will see that we got the application return this message here. This message here, that is a 1 ZKTeco device is connected, because I only have one ZKTeco device that is connected to this computer. One ZKTeco device is connected to this computer. Let's move on swiftly to step 3. In step 3 is where we open the ZKTeco device. Remember, you cannot be able to use your device until you open it, so you have to open it, and in this step is where we are calling this function for opening ZKTeco device. And if the ZKTeco device was not opened, it will return a null, and this is the message that you'll receive: error, ZKTeco device open failed. But in our case, because we were successful in opening the ZKTeco device, we got this message here: ZKTeco device opened successfully, in line number 74. So let's see whether we receive the same message on the command prompt during the opening of the ZKTeco device in step 3. So step 3 here, open ZKTeco device, and then we receive this message here: ZKTeco device opened successfully. In step 4 is where we are getting the width dimension of the ZKTeco fingerprint scanner, and in step 5 is where we are getting the height dimension of the ZKTeco fingerprint scanner. So why do we need the width and the height before capturing the fingerprint image? This is because your ZKTeco API needs to determine what type of ZKTeco device is connected to your computer, the one that you are using at that particular time. There are various types of ZKTeco fingerprint scanners. The one that I am using is a ZKTeco type 4500. There is a ZKTeco 6500. I think there is also a 7000. There is an 8500. There is a 9500. But in my case, I only have a ZKTeco type 4500. And for all those various types of ZKTeco devices, they have varying sizes for the images that they produce after finger is presented on the scanner for finger capture. Like now for the ZKTeco 4500, you can see that it returned 292 pixels for the width and 374 pixels for the height. So now with the width of 292 pixels and the height of 374 pixels, we need to get a product of these two, that is the width and the height, so that we can reserve a canvas area for where the image will be displayed. So for our ZKTeco 4500, we need a canvas area of width size 292 pixels and height 374 pixels, where the captured fingerprint image is going to be stored, or rather archived. So it's like deciding you're going to paint a picture on a canvas area, and then your canvas area is of size 292 for the width and 374 for the height. So this is also what is happening in the code. So we need the width and the height values so that we can get a product of the two, which you are going to allocate as the buffer size for the fingerprint image. So I think in this scenario I'm just going to explain both step 4 and step 5 together. Let me take you to Visual Studio Code to show you what happens. So in step 4, where is our step 4? Where is our step 4 starting from? Here, step 4. So before we proceed with step 4, I need to show you these things here. We will need the parameter codes that we are going to pass in the GetParameters function. So if the parameter code we are passing is 1, we know the application knows that we are trying to determine the value of the width. And if the parameter code is 2, it knows we are trying to determine the height. And then for the DPI, that is for the image resolution, if the parameter code is 3, it knows we are trying to get the dots per pixel inch, that is for the image resolution. But we don't need that to reserve what am I saying? We don't need the DPI to reserve memory for or rather memory buffer for the captured fingerprint image. And then this other bit here, let me just take you straight to step 4 to show you how we are calling that function, that is the GetParameters. This is step 4, where we are doing get with dimension. So we call this function here for GetParameters, and then we pass the parameter code width, which is 1. For the case of height, we will need to call the same function, but then we pass parameter code height. So at the very end, you will see that we output this message here: with dimension retrieved successfully. That is if we received a 0 after calling the ZKTeco parameters here. So in our case, you will see that in line number 105 we got this message: with dimension retrieved successfully. Let me show you that from the command prompt, this one here: with dimension retrieved successfully. And then we got this one here: image width is 292 pixels. So from Visual Studio Code, this is where that line is. This line here, line number 113, image width 292 pixels. So the same case happens for step 5, where we are trying to get the height dimension of our ZKTeco device. So when we are calling the GetParameters function, we are calling the param code height, which is actually 2. So once we call our GetParameters function, we receive this output here, and if it is a 0, I show the user this message: height dimension retrieved successfully. That is line number 131, and you can see from our command prompt, here is that message here: height dimension retrieved successfully. And then for this bit here, where we are getting the int value of the height, that is image height 374 pixels, and from the command prompt you can see here is that bit here. So far so good. I've been able to take you through step 4 and step 5. That is step 4 for getting width dimension and step 5 for getting the height dimension. So let us now move on to step 6, where I show you how the application does finger capture and the extraction of the fingerprint template. So moving on to step 6 in the Visual Studio Code. Here is step 6. So in step 6, you can see that we need the image buffer size, which is going to be a product of the image width and the image height. This is for the template, so we just put 2048, but this is the maximum, but your template every time will have a different value. So to capture our fingerprint image and extract the fingerprint template, we are going to call this function here. And note that this function is inside this loop here, where we are going to call it 20 times. If during any one of those iterations we receive a 0 from the result of this function here, we return this message: finger capture successful. You see this line here at line 171. Let me show you in the command prompt. This is that line here: finger capture successful. So if at any point during the iteration where we are carrying out those iterations for finger capture, we receive a 0 here. We know that there was a successful finger capture, and that is why we display this message here. That happens only when you present your finger on the scanner and it is successfully captured. Otherwise, the application continues to prompt you to present your finger on the scanner. And if you don't present your finger on the scanner during any one of those 20 iterations, this message here is displayed. That is at line number 197, that is fingerprint image not captured. This is what happened in the second scenario when we were running the application, but we were not presenting our finger on the ZKTeco device for finger capture. So in the event that there was a successful finger capture, this bit here, we run step 7 inside this bit. That is for displaying fingerprint image. So in step 7, display fingerprint image, and then we call this function here, display fingerprint, and then we pass the finger image buffer, the image width, and the image height. Remember, this fingerprint image buffer is returned from this function here. It is this one here. So when we call our display fingerprint, I need to take you where to this function is, so that you can see what is happening there. Here is that function here, display fingerprint. So it is taking in the image buffer, the image width, and the image height. Then remember at the very top where we're showing you the modules, remember the modules that we are importing. One of the modules we are importing is the sharp module. So this is a lightweight module that helps with the displaying images, resizing them, cropping them, but for our case we just needed the sharp module to assist us to save the captured fingerprint image in PNG format. This is the name of the file that I allocated it, and you can see from our image here, you see this bit here. Let me scroll it, let me bring it here. It is ZKTeco __ fingerprint _ image.png. So the name here of our captured fingerprint image originates from this file name here. So we are using the sharp module there to, let me minimize this or I just go straight to the code. We are using our sharp module here to save our captured fingerprint image bytes into a file, into a PNG file that we are calling ZKTeco _ fingerprint _ image.png. And then after that we display it. To display it, we are calling this exec sync function with the start command, and then we pass the image file, this one here. So you can see this image file here. It was saved in the same project folder of our Node.js biometric application, and you can even see it here in our do I call it the solution explorer? Do you have any name like that in Visual Studio Code? But here it is. So it was saved there when we captured it. Well, when I presented the left index on the fingerprint scanner, when the application was running step 6 for finger capture, it captured that fingerprint image and saved it in the, I could even show it to you in the project sources. Remember, initially, if you go back to the beginning of this video, these were the only files that I showed you at the beginning, but when the application was able to capture fingerprint image, it saved it inside this project folder path. So here is our image. This one was not there initially, but when the application captured it, it saved it here and displayed it using this command here, that is the exec sync, using the start. We call the exec sync, then we pass the start and the file name, and that is what opens the captured fingerprint image. Now that was for step 7, that is for displaying the captured fingerprint image. Oh, by the way, and when this was successfully done, we were able to see this message here, fingerprint image displayed successfully. This line here at line number 179. You can see it from here in our command prompt here, that is fingerprint image displayed successfully. Now let's move on to step 8 for displaying extracted fingerprint template. So remember, both step 7 and step 8 are running under step 6. That is, after they are running in step 6 only if there was a successful fingerprint capture. So let me take you to Visual Studio Code. I show you step 8. Step 8, here it is, display extracted fingerprint template. And to do that, we are calling, we're doing what? Yeah, to do that, we are getting our returned fingerprint template buffer. By the way, this one is being returned here in this function here. Here it is. So remember, this capture function is returning to us two very important items, that is the fingerprint image buffer and the FP template buffer. So for this one, I've been able to explain to you what happens and how we convert it into a PNG file and then we display it. Now let's talk about the FP template buffer. So the FP template buffer is base 64 encoded to a string. Remember, it is just bytes, the same way as the fingerprint image buffer. They are just bytes. So here we are base64 encoding it to a string, and then we display that string using console log. So when we call this bit here at line 189, that is console.log, that is the enc_fp_fp template. This on here, that is the base64 encoded bytes of the extracted fingerprint template. That is when we receive this output here, that is the hash code, this bit here, the hash code of the captured fingerprint image. This is what we are calling the fingerprint template. And now to the second last step, that is step 9, where we are closing the device. Let me show you in Visual Studio Code what is happening. So you scroll all the way here. In step 9 here, for close ZKTeco device, that is at line 204, we call this function for close device, and if it returns a 0, we return this message. We show this message, ZKTeco device closed successfully. That is at line 211. And from our command prompt, you can see this is what we got after at step 9. After step 9 was run successfully, we received this message here, ZKTeco device closed successfully. Now to the final step, that is use step 10. Yes. Yeah, I forgot to write step 10 here. I don't know how I forgot to write that. This is step 9. This one is supposed to be 10. Let me just remove this and type 10, then I save. Yeah, in step 10 here, in step 10, no, this one should be this message here. Why did I mix up these things? What am I doing? Need to have this here. Let me just copy this and have this here. Yes, that is how step 10 looks like. So in step 10 is where we are freeing up the allocated ZKTeco resources, and we call this function to do that. And if it returns a 0, we show the user this message, ZKTeco allocated resources freed up successfully. Otherwise you show the error. In our case, this is the message that was displayed in step 10 here, and here was our message, ZKTeco allocated resources freed up successfully. Basically those are the 10 steps that I implemented in this application to be able to capture a fingerprint image, display it, and extract and display its fingerprint template in our Node.js ZKTeco 4500 biometric application. This brings us to the end of this demo. Let me know what you think about this Node.js biometric application. If you have any challenges during the integration of your whatever biometric scanner that you are using, or any device, doesn't have to be a biometric scanner. If you are doing any integration on Node.js with a device and you encounter issues that you think I could help you with, please feel free to do so. Send me an email. My contacts are right there on the first comment, the pinned comment, or you can even check out my contacts in the description of the video. I would like to thank you for staying all the way to the end and for allowing me to show you my ZKTeco Node.js biometric application. See you in the next one. Bye bye.